Hey everyone! In this video, we are going to be doing a kinematic well problem. So let's get started. A rock is dropped down a well and it strikes the bottom in 2.4 seconds. We underline that, and how deep is the well? The typical equation that we use when talking about things that are falling or flying up in the air is d equals 1 half at squared plus vit plus di. And we'll just go through a little bit what these variables are. So the a, in all these cases when it's things falling, that's just the acceleration due to gravity. As long as you're on Earth, it's going to be negative 9.81 every time. The vi is the velocity initial. So unless you are throwing this rock straight down the well or tossing the rock up into the air, that velocity is going to be 0 meters per second. That would change if this was a problem where you were tossing a ball or launching a rocket. And di, that's our initial position. In this case, our initial distance or our initial height. And because we're just dropping a rock down a well, unless we told you that you're like 5 meters above the well and then drop the rock, you can pretty much assume that that's going to be 0. We have all the information that we need. Let's go ahead and scroll this up and find out how deep this well is. So the depth of our well, that's the d value here. We're going to fill in each of our variables. So it's going to be 1 half. And our acceleration is that acceleration due to gravity, negative 9.81. We fill in our time, which was given 2.4 seconds, and that's squared. Because both vi and di are 0, the rest of those terms vanish. So we're just left with that our depth is going to equal negative 28.25 meters. And that's it. We can write that the well is 28.25 meters deep. Now this strategy works whether you're trying to solve the depth of a well or the height of a cliff, anything like that where you're just dropping an object and waiting for it to land. It'll tell you the height or the depth. I hope that this was helpful. Thank you very much, and I'll be looking forward to seeing you next time.